We be working all day long, the push us Spani. We ain't playing no games, Sabatavi, Gani.
Good day, thread 11. Today we are still continuing with exponents and surds. So today we'll start with this question. So this question says, if it is given that 2 to the power x times 3 to the power y equals to 24 to the power 6, determine the numerical value of x minus y. Okay, so guys, this question is easy. Why I'm saying it's easy? So look here, we have 2 to the power x times 3 to the power y. We cannot multiply the bases here because we need to apply the laws of exponents. So I'm going to drop 2x times 3y. Now what I need to do here, I need to find the prime factors of 24. So remember guys, I showed you how to find the prime factors using your calculator. You just press 24, then you press equal sign, then you press shift, then you press fact. So it's 2 to the power 3 times x, times 3, sorry. So I'm going to have here 3 times 2 to the power 3. So can you see that guys, here we have the power 6. So I'm going to drop my left hand side, which is 2x times 3 to the power y. Which law I need to apply here? Yes, I hear you. It's law number 3. So what must I do? I know that this power must multiply every exponent inside the bracket. Remember here we have power 1. So I'm going to take my base. Then I'm saying 1 times 6. We know that anything multiplied by 1 remains the same. So I'm going to have 6 here times, then the base is 2. Then I'm going to say 3 times 6. Then we get 18. Understand? So what must I do now? I must make sure all the bases, all the same bases must be on the same side. So I'm going to divide both sides by 2 to the power 18 by 2 to the power 18. Remember, if I divide both sides by 2 to the power 18, I also need to divide by 3y both sides so that I can have the 3's on one side and the 2's on one side. So I'm going to divide both sides by 3 to the power y, then 3 to the power y. Understand? So this thing, guys, cancel this one. Now I'm left with 2x over 2 to the power 18. Yes. So this one, guys, 2 to the power 18, cancel this one. Now I'm left with what? With 3 to the power x over 3 to the power y. Now you ask yourself again, which law you need to apply? Yes, it's law number 2. Yes, it's law number 2. Now can you see that here the bases are the same? So I'm going to take one base and subtract the exponent. So I'm going to have x. Then if this 18 goes up, we know that the sign is going to change to become minus 18. Are we together? Then we have on the right side 3. Remember that here the bases are the same, so I'm going to take one base again and subtract the what? The exponent. If this y goes up, the sign is going to change to become what? Minus y. Yes. So I cannot apply that theory says that when the bases are the same, you drop the exponent. So I need to apply the basics of mathematics. We know that, guys, anything to the power 0 will always give us 1. So in order for me, the left hand side to be equal to the right hand side, if I can set this exponent to be equal to 0 and set this one to be equal to 0, the left and the right can be equal. Understand? Because 2 to the power 0 is 1, 3 to the power 0 it's 1. That's the only whole number that can make the left and the right to be equal here. So I'm going to say x minus 18 must be equals to 0. Or 6 minus y must be equals to 0. So now it's simple for y, guys. Just transpose 6 to that side, or you just transpose y to that side. So if I transpose y to that side, I'm going to be left with 6 equals to y. So that's the value of y. So for x, so just transpose 18 to that side. So therefore, x is equals to 18. Understand? But the question was saying, calculate, determine the numerical value of, for x, numerical value of x minus y. So it's easy now. So what must we do now? I'm going to say x minus y equals to, we know that the value of x was 18. So I'm going to say 18 minus, from the formula, your y was 6. So which means 18 minus 6, what do you get? It's 12. So therefore, guys, we can conclude that x minus y will give us what? 12. Understand? So that's your final answer for this question, guys. It's similar to the previous question that we did on the previous video. So the working is the same, or the procedure or the technique is the same. So I'm going to do question number 2, guys. Here we are given we must rationalize. All right, remember grade 11, the principle of rationalizing the denominator is to remove the sets. So the sets, the irrational numbers in the denominator. We know that irrational is the number that cannot be written as a what? As a fraction and have recurring decimal. So they are saying rationalize the denominator of the following and leave the answer in a simplest set form. Right. So guys, we have a here. What do we have? We have a, we are given square root of 8 over root 2. Remember, we said, guys, the principle of rationalizing the denominator is to remove the set in the denominator. So what must we do in order for us to remove this set, guys? I'm going to multiply by an identity element, which means 1 here. If I'm using 1 here, but I want to remove this denominator, I'm going to drop again 88 root 8 over root 2. So we know that if I say, guys, here root 2 divided by root 2, this thing, guys, is the same as 1. So it does not change this value, but we need to apply maths here. So we know that, guys, we did the laws of our sets. So if I say root 8 times root 2, so I'm going to take one root and multiply what I have inside. So this is 8 times 2 over, if I say root 2 times root 2, so I'm going to take, so guys, we know that root 2 times root 2 will give us 2. Understand? So here we're going to have 2 here. So I'm going to drop again 8 times 2, we get 16. Wow, now we know that 16 is a perfect square, all divided by what? By 2. So now root 16 give us what? Give us 4. So then the denominator is 2. So 4 divided by 2, we get what? 2. So that's your final answer here. Because even if you can press on your calculator, root 8 divided by root 2, that's 2, the answer. So that's your answer, guys. So we go to number B. So what do we have? Number B. Number B, we're given 2 over 5 root 2. Understand? So still, guys, the technique is still the same. So I'm going to multiply, because the aim here is to get rid of the set in the denominator. So I'm going to multiply by 1 here, which is the same as 2 over 5 root 2 times, remember I need to get rid of these, guys. I'm going to say 5 root 2 over 5 root 2. Okay, so now it's easy to move. Now I'm going to say 2 times 5, then we get 10. Then 10 what? 10 root 2, because it was 5 root 2. So if I say 2 times 5 root 2, I'm going to get 10 root 2. over, remember here guys, 5 times 5, you're going to multiply the coefficient. Consider this one as 5x times 5x. Consider this one like this. So 5 times 5, you're going to get 25. Then root times 2, root times root 2. So this root 2 guys times this root 2, what we'll get? We'll get 2. Understand? So then here I'm going to have 10 root 2 over 2 times 25 is 50. Now it's easy now guys. Then you're going to ask yourself, 10 goes to 10 1 times, 10 goes to 50 5 times. So your answer is going to be root 2 over 5. So that's your final answer for number B. So I'm going to take number C, then we move to number E guys, because the working the technique that you did on this number C will be the same with this number D, but the difference is the sign. So if we take number C here, you will see, remember guys, you can pause the video and try to attempt this question on your own. So number C guys, we are given 2 over 1 minus square root of 3. Remember guys, here the aim is still to get rid of the set. So the principle is of the rationalizing the denominator is to remove the sets. So I want to remove this set. So I'm going to multiply here by 1. So we all know that guys, this thing is the same as 2 over 1 minus root 3. Remember, if I rationalize the two terms here, then I have the sign between. So I'm going to say it's 1 plus, you change the sign. If it was plus, you were going to say minus here. So plus root 3 over 1 plus root 3. Understand? So since this term are two terms, so I'm going to say this multiplied by this, numerator times this, so which means I'm going to have 2 into 1 plus root 2. I'm going to put them into brackets because there are two terms. If guys, you can notice here, this thing and this thing is the same as x minus 2 and the x plus 2. So it's a difference of 2 squares. So all in all guys, okay, let's show it. Let's take the wrong road, the long way. So I'm going to keep this one as it is. So if I say 1 times 1, I get 1. 1 times positive root 3, we get positive root 3. So then if I say negative root 3 times 1, we get negative root 3. Then negative times a positive, we get a negative. Then root 3 times root 3, we get 3 guys. Understand? So what will happen to root 3 and root 3? Yes, they are going to cancel out. So now I'm left with what? I'm left with 2 on the numerator plus 1 plus root 3. Then on the in the denominator, we're left with 1 minus 3. So 1 minus 3 guys give us what? Give us negative 2. So it's easy now. So I'm going to say here 2 divided by negative 2 is negative 1 into 1 plus root 3. Then you need to open your brackets. So a negative 1 times positive 1. So it's negative 1. Negative 1 times positive root 3 is negative root 3. So that's your final answer for number C guys. So for number D, you're going to do the same thing guys. You just change the denominator sign and make it negative. So what you need to do on number D, I said that we're not going to do it, but I'm going to show you the first step. Since we're given root 2 over 4 plus root 2, so it's simple guys. We just put an identity element here. So since it's 4, we're going to say 4 minus root 2 over 4 minus root 2. Then you continue guys. So then you continue. So I want us to do number E so that we can see what we want. So if we do number E guys, Number E, we are given root x over x plus y over root x. So they are saying show that root x over x plus y over root x can be written as root x squared into y plus 1 all over x. Okay, so I can put this one as it is so that I can know what I want here. I can see what I want to show. Alright, so I want to show this side is the same with this side. But bear in mind, guys, I can take this side and make it to look like this because this side is not simplified. So I'm going to consider this side as my left and this side as my right. So I'm going to take the right side, guys, because I can see that my left will be easy if I'm taking the right hand side. So we have root x over x into y plus 1. Okay, so guys, can you agree with me that if I multiply this one, if I open the brackets here, I want to open the brackets, this will multiply here and multiply here. So I'm going to have y times root x. So root x times 1, we are going to get root x over x. Okay, now we can see, guys, this denominator divide here and divide here. So I'm going to split the denominator. So in other words, I have root x, this root x, guys, divided by x, this one. Then we keep the sign. Then I have y over root x times root x over x. Now we can see this is what we want here. So I'm not going to change this side. Plus, then guys, we know that the square root is the same as 1 over 2 over x. Then we apply the laws of exponent. Which law I need to apply here in x and the x? Yes, it's law number 2. So I'm going to have square root of x over x plus y over x. Remember, we have power 1 here, it's 1. Then if this half goes down, the sign is going to change to become what? Minus half. Okay, so which means root x over x plus y over x to the power 1 over 2. Now guys, we said here root is the same as x to the power half, so which means now I have 1 over 2, which is the same as square root. So here is the same as x to the root x, because we said, guys, half is the same as square root here. So can you see, guys, this is the same with this question. So we can take this one also and try to make it to look like this. So let's try to take the left hand side and see if we will get the same answer. All right, so remember, guys, I'm going to we're given root x over x on the left side over root x. Okay, so guys, what I'm going to do here, I'm going to put my division here. So I'm going to multiply the denominator. So x times root x, it's x root x. Then I'm going to say root x times root x, it's a root x times root x. So then we keep the sign. So y times x, so it's xy. Okay, so remember, guys, what we want to prove here. I'm taking now this side, I want to make it look like this one. Okay, so root x times root x, guys, we know that will give us x plus xy over x root x. Okay, so now what is common here, guys? We know that the common factor here is x. So if I take out x, then I left with 1 plus y over what? Over x times root x. Okay, so guys, so I need to be careful with this one. I need to be careful. So I'm going to work with this one, with this x and this x, guys. Understand? So I'm going to work with this x and this x. So here I have x into 1 plus y over x. We know that, guys, square root, guys, is the same as 1 over 2. Understand? So I'm not going to apply law number 3 with these bases. I'm going to apply law number 2 with this x and this x, the red one here. So we have the power 1 here. So this half must go up. So now I'm going to have x to 1 minus half into 1 plus y over this x. Understand? So can you see that, guys? 1 minus half will give us half into 1 plus y over x. We know that, guys, half x, anything to the power half, is the same as square root of that something. So here is the same as square root of x into y plus 1 over x. So this is what we want, guys, because they were saying write this, show that this can be written as this. So this is what they want here. So this is your final answer for this E, guys. All right, I hope that you are good, guys. You are fine with rationalizing. So, guys, let's take one question, the last question. It's the last question that will deal with surds, guys. All right, we have this question, guys. They are saying show that root 12 minus root 75 over 3 to the power 3 over 2 equals to -1 without using a calculator. Remember, guys, when they say without using a calculator, they don't mean you must take your calculator away from you. So I'm going to copy this question down. I have root 12 here minus root 75 over 3 to the power 3 over 2 equal to -1. Remember, when we are dealing with sets, guys, take a note that if I have square root of something, inside the square root, I must make sure that I have the prime number, okay, times the perfect square. Okay, I must have the prime number times the perfect square, or the perfect square times the prime number, so that I can use what? The laws of exponents. So here, guys, I have root 12 minus root 75 over 3 to the power 3 over 2 equals to -1. So this is left and the right. So I'm going to take the left hand side here. I have this one. Okay, remember, guys, since I have this thing here, so this one is the tricky part here. 3 to the power 3 over 2. Remember your root definition, guys. If I have m over an, so this is the same as a, this one becomes your numerator, n over m. So it is written like this. So I will take it to this form. So I'm going to have square root like this. Then remember, this was inside the square root. So it's 3 to the power 3. Then we have 2 outside. Understand? So then it's root 12 minus root 75. This thing, guys, we cannot write I. It doesn't matter even if we don't write 2 here, because we know that always the degree here, if it is not written, is 2. So now I have 3 to the power 3. 3 to the power 3 will give me 27. Understand? So now we can try to find the prime factors times the perfect square. So you can do like this. 12 is equals to, then you press shift again, then you press fact. So can you see that 2 to the power 2 is what? It's 4. 4 is a perfect square. So now I can change this one, guys, to be 4 times 3 minus square root. Then I need 75. You can say 75, then you say shift, then you say, and then you press fact. Then you have 5 squared. We know that 5 squared, guys, is 25. 25 is a perfect square. So which means it's the same as 25 times 3 over, then you can find 27 again. then you press shift, then you press fact. Can you see that is 3 squared? But we can break that 3 squared, guys. I mean 3 cube, and it's 3 cube. We can break 3 cube to be 3 to the power 2 times 3 to the power 1. We can see that 3 squared is 9. So which is 27, guys, is the same as 9 times 3. Alright. So now let's apply law 1 of sets, which is multiplication. So I'm going to split this thing to have root 4 times root 3 minus root 25 times root 3. So over root 9 times root 3. So I hope that you agree with me that root 4 is the same as 2. Then times root 3 minus, you all agree with me that root 25 is the same as 5 root 3 over root 9 is the same as 3. Then we keep the rational here, irrational. So consider this one, guys, as 2x minus 5x. So 2x minus 5x will give us negative 3x. So here 2 root x minus 2 root 3 minus 5 root 3 will give us, guys, minus 3 root 3 over 3 root 3. Can you see that, guys? 3 root 3 divided by 3 root 3 will give us 1, but we have negative here. Negative divided by positive will give us negative, which is their final answer, because they were saying show that root 12 minus root 75 over 3 to the power 3 over 2 equals to negative 1. So this is what we got here. So now we can conclude that this is equal to this one. All right, guys, this was our last question for this video. Please, if you didn't subscribe, don't forget to subscribe and like the video and share the link to your friends. See you next time.